Okay, for this problem, we now are looking at determining the area of surface generated about the y-axis. Okay, so we'll be integrating over y, but for what we have right now, we have the function given as if we were going to integrate over x, but we were going to make the necessary adjustments. Now for what we have given, okay, we have the function y is equal to the natural log of x, as x goes from 1 to e to the fourth. And again, we're going to adjust this equation, writing in terms of x equals. And let me mention a few things here. Okay, if x is 1, now we have the natural log of 1 would be 0, so y would be equal to 0 at the lower limit. And also going back to pre-calculus, if you have natural log of an exponential base e to the fourth, that is going to go to the degree to which e is raised. So natural log of e to the fourth is equal to 4. And so we have, in essence, carrying over what we have in terms of x of those in y equals natural log of x. As x goes from 1 to e to the fourth, this signifies that for the corresponding value in y, and the minimum is going to be at 0, the maximum is going to be at 4. And so if we were to rewrite this equation in terms of x equals, we can get rid of the natural logarithm notation by taking the natural logarithmic base e, to which we will treat y, and the natural log of x as powers. So you have e to the y is equal to e to the natural log of x, which again is going to go to x. So we have, working with both sides, we have e to the y is equal to x as y goes from 0 to 4. And using the commutative property of equality, we have the x is equal to e to the y. And working with the derivative of x is equal to e to the y, okay, well, e to the y stays the same, so the derivative of dx over dy is equal to e to the y, and we're going to square this out. And so for the square of e to the y, and thus the square of the derivative of dx to dy, we have at e to the 2y. And in terms of what we have in the initial setup, so as to determine the area of surface about the y-axis. Okay, again, we have for the general terms, okay, we have going from, say, point C to point D, we're now looking at 2 times pi times f of y, and then we have times the square root of 1 plus the square of the derivative dx to dy, and again integrating over y itself. So your f of y is going to be that which x is set equal to, and again the square of the derivative, okay, this will be from e to the 2y. And as we substitute accordingly, we have lined up, okay, this time we have that s of y, okay, again you have going from 0 to 4 in y, 2 times pi times e to the y times the square root of the sum of 1 plus e to the 2y dy. And again, this is a graphing calculator problem. This is not an integration that is to be done by hand at this stage. And now any techniques that you have worked with in the past, this might be stuff like the trapezoidal rule, Simpson's rule, or any other type of numerical integration that you have encountered. And regardless of the technique, okay, we have in the determination of the value as y goes from 0 to 4, okay, we have, say, to the nearest 2 decimal places, that the area of surface of the solid generated about the y-axis is about 9374.06 square units.